Okay, in this lesson plan I want to go over how to calculate the current yield on a bond, the yield to maturity, or as in Excel what we use is a rate function, and how to find a price on a bond. And in all these examples we're going to make an assumption that the future value when these bonds mature is going to be $1,000. Realistically, if you and I were to go out and buy a bond, we'd probably have to come up with $100,000 or more, but a lot of times what Wall Street firms will do is they'll break apart the bond. That is, they'll sell us a piece of that, and we could afford to pay $1,000 as opposed to $100,000. But first, we're going to look at problem number 6 on page 177. And it asked us, a bond that has 10 years till maturity, a coupon rate of 8%, and sells for $1,100. It says, what is the current yield on the bond, and what is the yield to maturity? Well, first, the coupon rate is the original rate stated on the bond. So if it was originally issued at 8%, that's what it would pay on a coupon. If we took, for example, equals $1,000 times 0.08, it would say that we would receive a payment of $80 at the end of every year. And for the textbook purpose, when we look at these examples, we're assuming an annual basis. The reality is that most bonds pay semi-annual interest, and I'll show you that in a little bit in problem number 11, how that would change if we adjusted it for twice a year as opposed to just once a year. But for a lot of the examples, for the theory's sake, to explain how the process works, they use annual examples to keep it simple. Well, the first, if we know that the payment is $80, to find out the current yield on this bond, what we want to do is take the payment received in that given year, and we want to divide by the current price someone will be paying for that bond. And right now that price is $1,100. So if I took the $80 divided by $1,100, it would tell us that the current yield is about 7.27%. So again, when you think of current yield, think of just in that time period, what it is in the given year, what you receive versus what you paid for something. And that's much different than yield to maturity, which looks at your return over the entire investment horizon. That's what we'll look at next. Now, for defining yield to maturity on a bond, we're going to go to f of x, and we're going to go to financial, and we're going to use the rate function. So if you click in there and type in the letter R, it takes you right to the rate. So I'm going to hit OK here. You'll notice it asks for the number of periods, and in this example we have 10 years till it matures. The payment, that was that $1,000 times 0.08, so it was $80 at the end of every period, at the end of every year. And it said we paid $1,100 for the bond. And again, remembering that the future value, we're always going to use a positive 1,000 for the future value. So for the yield to maturity, or rate in Excel, we get 6.60%. So we click OK here, and again, always go out 4 decimal places when adjusting this. We'll go 1, 2, 3, 4. So the yield to the investor, or the yield to maturity, is 6.60%. That is, if they bought the bond, held on to it for 10 years, and received $1,000 at the end of that 10 years plus $80 at the end of every year, that's a 6.60% return for them. All right, now in the other question, it asked us for the bond pricing. It says a General Motors bond carries a coupon rate of 8%, has 9 years until maturity, and sells at a yield to maturity of 7%. And again, that inverse relationship between bond prices and interest rates. In this case, the original coupon rate is 8%. That's constant. That's going to stay fixed. But it says that current interest rates have dropped to 7%. So we should expect that when interest rates drop, present values will go up. So the price of this bond will go up. And if that was the opposite case, if interest rates were, say, at 10%, and the bond was originally at 8%, will interest rates rise, we'd expect present value of the bond to go down, or the price to drop. But first, it asks, what interest payments do the bondholders receive each year? Well, again, this previous example we had in problem 6, it was equal to 1,000 times 0.08, so the coupon rate, and they would get $80 per year. Okay. And then it says in B, at what price does the bond sell? Assume annual interest payments. Again, we're going to make this pretty simple, just keep an annual interest payment, and I'll show you in a second here what if it was semi-annual. But we're going to pull up f of x, and under financial we're going to look for present value, and we have some experience already with present value before. We're just going to be using this slightly different. So I'm going to put in PV, click OK. Our rate is the current rate in the market, or what they tell us is it sells at a yield to maturity of 0.07. So put 0.07 there. The number of periods is 9 years. The payment is the coupon payment, 1,000 times 0.08, the $80. And finally we said that we're always going to have a future value of 1,000. So we look at that, and it tells us that we'd be willing to pay $1,065.15. So this bond would sell at a premium because it's higher than the $1,000. And that's a good thing. That's a capital gain for an individual. If it was below the $1,000, that would be a capital loss if they had to sell it. Now the other thing I wanted to show you is, let's say that this bond, instead of it being once a year, it was twice a year, which most bonds are. And this is outside of the homework question. We're just kind of saying, well, what if this was the case? But if that is the case, what we're going to have to do is we're going to take this 0.07 divided by 2, and since that's for 9 years, but it's twice every year, we got to multiply that by 2. So we actually have 18 periods. And the last thing I'm going to do is that we don't receive $80 every 6 months. We're going to get $80 divided by 2, and we're going to get $40 every 6 months. So equals 80. Let me take that equal sign out. Just say 80 divided by 2, so we get the 40. So what you'll notice is that the price changed slightly, just a little bit, but the price did increase. That's because we're receiving that payment more frequently. We're getting $40 every 6 months. All right. Well, the last thing we're going to look at in Part C, it says what will happen to the bond price if the yield to maturity falls to 6%. So let me go back and take this out. We have 9, and we're going to put the interest rate in now as 0.06. Let's go back to our original annual payment of $80. And what happens there is that you see that the present value went up even more. So now it's at $1,136.03. And again, the idea here is because interest rates are dropping more, current interest rates went down to 6%, the present value is going to increase up. And again, a thing to remember is that with bonds, the longer the duration to maturity, the longer the number of periods, the bigger the impact there is going to be to that present value. So that's why long-term bonds, if any interest rates change, are going to have a bigger impact in the price volatility. Where if it's a shorter range, there'll be less impact to the volatility of the present value. So again, when you think about a bond, what we're really doing is we're discounting back all those future cash flows. That $80 discounted back 1 year, $80 discounted back 2 years, all the way up to 9 years. And we're summing up all those discounted cash flows to say, what is it worth today? So this, again, why that concept of present value is so important in finance. What is something worth to me today? Okay, well, that ends our lesson on present value, yield to maturity, which is rate in Excel, and current yield.